Welcome to the Computer Systems unit of our Higher Computing Science course. The first topic area we will look at in this unit is data representation. This is how the computer stores and represents numbers, text and images. The first area we will look at is how the computer stores and represents negative whole numbers. You can now see our learning intentions for this area. As always, we have some success criteria which can be used as a measure of your progress in this lesson. This can now be seen on the screen. In our first example, we will convert the negative number negative 85 to binary. Our first step will be to lay out the unit headings for 8 bits, as we did in National 5 for binary conversion. As we can see, those are 128, 64, 32, 16, 8, 4, 2 and 1, with 128 being the most significant bit and 1 being the least significant bit. In step 2, we will lay out negative 85 in its positive form, therefore 85. We will do this using 0, 1, 0, 1, 0, 1, 0, 1. 64 plus 16 plus 4 plus 1 will give us 85. Step 3 will involve inverting the binary number that we have just laid out. That means we turn the zeros to ones and the ones to zeros. And our final step will be to add 1. We start at the least significant bit, which is the column heading 1. In this case, we can add 1 to this heading. We now have the binary representation of the negative number negative 85. This is as follows: 1 0 1 0 1 0 1 1. In our second example, we will convert the negative number negative 120 to binary. Step 1 will again be to lay out our unit headings for 8 bits. Step 2 will lead us to lay out our negative number in its positive form. In this case, 0, 1, 1, 1, 1, 0, 0, 0. In step 3, we will invert the number. Again, this means turning our zeros to ones and our ones to zeros. And our third and final step will be to add 1 to our inverted number. Now, in our first example, it was easy to do this, as our least significant bit under the column heading 1 was a 0. Therefore, it was easy to turn this to a 1. In this case, that first column already has a 1 in place. We therefore change this to a 0 and move to the next unit heading. Again, this will have a 1. We therefore change it to a 0 and move up to the next unit heading. This again has a 1. This again is changed to 0. And we do this until we reach a unit heading where we can convert to 1. In this case, it's under the unit heading 8. This is changed to 1. Once we do that, the rest of the bits remain the same. We now have the binary representation of our negative number 120. 1 0 0 0 1 0 0 0. We will now look at the range of 2's complement numbers we can represent using 8 bits. When we're using 8-bit 2's complement, the range of numbers that can be stored changes when compared to 8-bit storage of positive numbers. The reason for this is because it is necessary and we need to include the negative numbers within our range. The lowest value that can be represented with 8 bits is negative 128, and the highest value is 127. This means the overall range is negative 128 to 127. This does include 0, so 256 numbers in total. We use a calculation to help us work this out. The calculation is shown on the screen just now. Negative 2 to the power of n minus 1 to 2 to the n minus 1 minus 1, where n represents the number of bits we are using. So when using 8-bit 2's complement, the amount of numbers that we can store and represent is 256. That is 2 to the power of 8. For a positive number, this would give a range of 0 to 255 as suggested earlier. But we are using 2's complement, and as such, negative numbers must come into that range. Let's work through this example using the formula we discussed in the last slide. In this case, we're going to use 8 bits. We represent n as 8. Negative 2 to the 8 minus 1 to 2 to the 8 minus 1 minus 1. This means we have negative 2 to the 7 to 2 to the 7 minus 1. As we know, negative 2 to the 7 is negative 128. To 2 to the 7, which is a positive number, which is 128, minus 1, which gives us our final range of a negative 128 to 127. This range will include 0. Thank you for listening. Please subscribe to our YouTube channel for future updates and videos.